Okay, so let's pick up where we left off last time, and hopefully we can take a couple of peeks into Unity. Did everybody get Unity downloaded on their machine over the weekend or something along those lines? Did the trick fun, did it work to restart it?
Yeah.
Just restarting it worked, or hotspot worked?
Restarting it.
Oh, okay, weird. Yeah, so everybody has it on their machine, and when we start doing stuff, we'll have to see whether or not your machine can keep up. Chances are it'll be able to keep up with the early stuff, but it might get to the point halfway through the semester or something like that when we're doing more animation stuff that your machine just becomes like abusive to use. Like you're waiting 3 minutes before keystrokes between keystrokes, but hopefully by then where everybody has accounts to the machines in the lab over here where you can come in and use fast computers and that kind of jazz. Okay, so we talked about the stuff with game design, types of programmers, what the game engine actually does for us. Mostly, we could think of it as mostly physics and AI these days. Somebody else is making the animations and probably making our design elements and things like that. We talked about kind of the two big game engines, public game engine competitors that are out there, Unity and Unreal Engine. We're using Unity, which has kind of become, in my view, the industry leader. You probably can find people who would disagree with that and think Unreal is, but I think Unity has a lot of momentum right now with some big partners, and I think you're going to keep seeing them become a bigger and bigger deal, and Unreal becoming a less deal. We talked about the scripting language itself. Unity uses C#, which is a modern language that a lot of developers already are familiar with the syntax for. Although it's not using it from a compile perspective. We talked last time about how compilers work, converts from high-level language to a low-level language. We talked about that difference between the source language, the architecture, and the actual operating system. How do those three things play together? For instance, if we were to have a quiz today and I asked something about that, how would those three elements play together? When we use a compiler, why do we need all three of those pieces of information in order to take C++ code, let's say, and turn it into an executable for a particular machine?
It's like the architecture, like it needs to know the architecture so that like it knows how many of the magic tricks to use and like which ones to use in order to compile the code like for that specific CPU. And then
or what magic tricks it has available.
Yeah.
Okay.
Yeah.
That's for the architecture.
And then like the operating system, like Windows and Mac OS like uses the like the different hardware differently, and like there's different because of that, like different programs have to run differently, and then like with like Mac OS you need different code for that, I'm pretty sure. No, you don't. But then like yeah, I'll be good with that.
I'm gonna stick with that answer. Anybody want to add, subtract, multiply, divide? Okay, so spot on with the architecture, right? Depending on which architecture we're using, we have potentially have a different set of magic tricks that we are working with, and it goes even a little, if we say we're talking about games today, a majority of games are going to run, a majority of desktop games are going to run on top of the broad Intel architecture, right? Why might we target the Core i7 5th generation processor rather than the Core i7 9th generation processor? Why might we target an older processor for compiling? Yeah, larger number of people have access to that processor. And since current processors are supersets of the previous processors to a point, more people then would be able to run your your code. Now, the OS itself makes a difference because OS, an operating system, it's the liaison between us and the actual hardware, but each operating system has an API associated with it. So we're going to call this OS API. What's an API? We've seen that, those letters next to each other before. Okay, well, what is that?
It's like a I guess it's like a made thing for other people to use. So like Google has a bunch of things with maps that you can incorporate into your own projects.
Okay.
Work on what they create rather than you writing certain things
From scratch, or you might not even have access to, right? Okay, so an API is effectively a library, a collection of hooks into a what would I say? Hooks into a competency collection. That sounds funky, but I think it's pretty accurate. That you may or may not have public access to. But I think the easier way for us to think of it is when we talk about the architecture of a CPU, those are hardware magic tricks. When we talk about the API of an operating system, we can almost think of it as the architecture of an operating system, although architecture implies hardware. Those are the magic tricks that the operating system knows how to perform, okay? Or Google Maps knows how to perform. So if you want to use the Google Maps API, they say, here's a collection of magic tricks that we're exposing to you. This is what each one does. You're allowed to call these guys. And each one of those performs a task. Similarly, for an operating system, they say, here's the collection of magic tricks that you have available to you. Maybe we have like syswrite, which writes something to the screen, things like that. Now, typically, these guys, a synonym for those magic tricks are called system calls. Okay, so these are system calls, which are calls to a program on an operating system that perform some task, perform operating system level tasks. Okay, so that OS API, we can think of as the magic tricks provided by a particular operating system. So if you are targeting Windows 7 or newer, since Windows 10 is very likely a superset, well, the API of Windows 10 is very likely a superset of the API for Windows 7. When I say superset, what does that mean?
like inherits everything.
Yeah, so it has everything that it used to have, plus probably some new stuff, right? So if we're targeting Windows 7 as our software-based architecture, then we're going to compile for the magic tricks that were available in Windows 7, which should also then be available in Windows 10, even though we might be leaving some magic tricks on the table that were introduced in Windows 10 that we're not requiring for our game. Make sense? So back to this slide, when a compiler is ultimately going to produce that low-level code, ultimately going to produce an executable, it needs to produce something in terms of the magic tricks that the CPU you're targeting understands, as well as the magic tricks that the operating system you're targeting understands. That makes sense? Those are the Legos it has to play with. So it has to build an executable in terms of those Legos. All right. Now the source language, that's the compiler needs to know what language it's converting into that stuff. So you can't use an Objective-C compiler to compile C#. It should know about the source language. Okay. Now in Unity, we're going to be using the C# language for scripting. And under the hood, it probably does compile that to a certain extent, but it's going to likely compile it down to a intermediate language that Unity understands. Because you can take a Unity project and work on it on Windows, and you can convert over to a Mac and pick it up right where you left off over on a Mac. And from any of those platforms, similarly, you can do it on Linux. From any of those platforms, you can build your project and export your project for Android or iOS or Windows or Xbox or PlayStation. You use this one central tool that is Unity to export your project to any of those platforms. Now, depending on what platforms you're using, you might have a different set of tools that Unity is going to be cool with you using. So for instance, if you're making a Windows game, you're probably not going to leverage Unity's built-in touchscreen stuff for, that you would usually use for mobile apps, right? Even though we do have some touchscreen laptops now, that's not the way we're interfacing with direct applications, right? You're more using it to launch an application or something like that. It's not our sole means of interfacing with it. So you might have to make some decisions with how you're writing your game if you're going to make it cross-platform. So when we say a cross-platform game, we want this guy to work on multiple platforms, right? So, if you're a console gamer, a majority of games come out for both, let's just say the two big consoles are Xbox and PlayStation. You throw the Nintendo, what is the current one? Wii U?
Switch.
Oh, the Switch is the current one, yeah. You can throw that in there. Switch is probably closer to the other ones than Nintendo's been in a while, but let's still put that on the side. So let's say Xbox, PS4 are relative equal powerhouses. So if you are targeting both of those guys, it's probably an easier task than targeting very dissimilar platforms. Like if you're targeting PlayStation 4 and Android, for instance, you might have to rethink the interface of your game for one of those platforms, where Xbox versus PlayStation 4, the controllers have the same number of buttons on them, even though the buttons are in a little bit different place. That kind of stuff. You can kind of build them as equivalent products. But this is another thing that Unity does for us. So this guy provides tools for targeting different platforms on which our game will run. Okay. Now, for us in here, at least at the beginning, when we get into game programming too, we start looking at maybe targeting some different platforms, but we're going to run our games on our computer, either Mac or Windows, and there's not going to be any difference because for the most part, we're running our games off of keyboard and mouse. Okay. So that's the cross-platform stuff. All right. So now let's start talking about Unity in general. And we'll do this. I'll launch Unity in the background here. Well, here, I'll go ahead and get it launching. So this is the latest, greatest one that we downloaded last time, Unity 2018 2.5 F1. You will notice that Unity comes out with updates somewhat often. I wouldn't necessarily be inclined to immediately jump into every single update. I'll probably use this version for the rest of the semester. Sometimes you could run into some incompatibilities between updates or something like that. So if everybody gets 2.5 F1 and just sticks with it, then we should all be on the same page. Sound good? Most of the time there aren't problems, but I've seen it create some problems. So why screw with it when it's probably just a little tiny bug fix or something like that. All right, so I'll go ahead and launch this guy. Man, that was a lot of stuff.
It's early in the morning.
Okay, so you can go ahead and you can create an account with Unity. It doesn't cost you anything. I'll go ahead and log in here. Okay, so I'm going to create a brand new project. And it's going to ask you, where do you want to store it? What type of template? So here, I'm going to call this guy CSC355 starter one. And I'll go ahead and let it store in this Awesome Fat Documents GitHub, because I'm going to be showing you how that works here in a few minutes as well, or next class, one of the two. Whenever we're ready to save it, so I can kind of show you an easy way to distribute your stuff in the cloud and then launch it in other programs. For template, you can choose 2D, 3D. You can have other things. I've actually never used any of these other ones. VR. I'm assuming that's for mobile VR since it says lightweight. But in any case, we're only going to be messing with 3D in here. Adding VR support, which we will do at some point this semester, you'll actually notice is pretty easy. The difference between a VR game and a normal 3D game is the camera. So in a 3D game, we're going to have, you might have your dude on the screen and the camera kind of sits behind him and follows him around, right? In a VR game, the camera becomes our head. So it automatically moves when we go this way, we turn our head, that kind of stuff. So we don't have to worry about actually translating the camera because the camera is going to move on its own. And what we do is we drop in, we're probably going to use Steam VR as the API for VR stuff because it's kind of cross-platform compatible with all the different ones. But we drop in their camera rig that does all the magic of tracking headset, tracking hand controls, all that stuff. Okay, so really the difference between a VR game and a normal 3D game is the camera that we use, and then the controls that we create for it. If you're writing a video game that's off of keyboard and mouse, you're going to probably use the WASD keys, that stuff for movement, and maybe your mouse becomes your guide to look around or something. If you're writing something for Xbox, you're going to do it in terms of the joystick controller dealy thing. Well, if you're doing it for VR, you have to consider, well, if I'm doing this for your Pro VR, your HTC Vive, or your Oculus Rift, well, you have two hand controls that have some buttons on them where you're going to write it for those buttons and those movements for those hand controls. If you're writing it for like an Oculus Go or one of the other mobile headsets where you only have one controller, it's only tracked in 3 degrees of freedom, well, you're probably not going to be reaching down to pick something up because it's not going to track it that much. So you're going to have to imagine the controls for your game in terms of that controller. Those all then become human decisions about how our game works as opposed to a drastic difference in how we will build the game. That makes sense? So you would build the game the same way. You could use the same exact world. One thing you do run into a little bit with VR that you kind of get used to over time is, let's say you take a normal 3D game, and we've seen that in some of the industry games, like I think Elder Scrolls Skyrim. So this was a popular game that's been re-released 500-600 times, something like that, right? Don't they just keep putting like, here's a 2% increase in graphics, give us another $60? And now they have the VR version of it. So what did they do? They took the original game that was, they have it in what probably their own internal game engine. They dropped a camera rig into it for VR into the world that already existed. They removed the perspective that you had from your, because your perspective was in the cutscenes was from the eyes of your guy, and then during gameplay you saw your guy on the screen, right? You were kind of hovering over his shoulder. Is that how Skyrim was? Or was Skyrim always you were inside of his head?
You play both ways.
Okay, you could choose. Okay, but regardless, you had to go from that to dropping that camera rig in there. And one issue you can sometimes run into is the world is either too big or too small relative to now the person that's in the camera rig. So if you've ever been on a VR setup, and when you first set it up, it wants to know how far you are from the ground. So when you're in there, it kind of can portray you in the right way. So sometimes if you take a game that you wrote one way, and now you drop this camera rig in there, you're either in a land of giants or you might be the giant, one of the two. So you might have to do some scaling with the stuff or some changes in order to get your guy sized right so he fits through doors and that kind of stuff. But something to kind of consider. All right, so 3D template, store it wherever you want. I'm going to put it here because I'm going to show you the GitHub dealy flippy thing. I'm going to go ahead and hit create project, and it's going to create a folder that has a whole bunch of crap in it. That is the Unity way of doing things. And sometimes when you first launch it, it takes a little bit longer. This is probably extra sluggish right now because I'm also screen capturing and stuff like that. But okay. Yeah, look at that. There's already a new version of this since last week when we went to when we went to download it. Everybody has downloaded it. Do we all have the version I have, not this 0.5? We all have 0.2. Okay, it probably doesn't matter, but I'm gonna go ahead and I'm gonna say skip new version. So I'm not gonna get sucked in. It's probably a fair thing to say, definitely update for major revisions, unless you're in the middle of a game design. If you're in the middle of a game design, I would say don't update. Finish your game using the version you're currently using, unless they just release some feature that you really want to take advantage of, because you might have to go back and fix a bunch of stuff. You might as well just keep the status quo, get it released, and then after it's out there, you built your executable and stuff like that, and you have a breathing time, you can grab the new version and make the tweaks that you might need to make. Okay, so let's do an introduction of what we're dealing with here. I'm actually going to rearrange my screen somewhat, but I'm going to give you the default view here to begin with. Let me scooch some stuff. Just going to scoot that over. It gives us a little bit more space. This services stuff is something we're not going to use probably at all in here, but you kind of notice this is stuff that you might use for some video games. For instance, if you're doing mobile things, you might want to integrate ads into your game, analytics for what screens people are clicking on, things like that. You might want to cloud build is actually kind of an interesting thing. If you have a kind of a crappier computer, when you actually go to build your games, you can utilize Unity's cloud to do this. We actually are not going to spend that much time building our games because most of the time we're running it locally, so we're just going to hit the play button. So building means, like, if I'm writing a game for Oculus Go, for example, I could test it on here to a certain extent, but in order to actually see it in VR, I'm going to have to then export it. I have to do a full build, export for VR, then put it onto the device. And that build can take some time. So if you have a very slow computer or something like that, this build time might take 15, 20 minutes, something like that. So in those situations, you might want to do a cloud build. For us, you hit play and it's running it live on your current machine. Won't be a big deal. Here's collaboration tools. This is stuff, if you've worked with tools like Visual Studio and things like that before, almost always the free version of, like, for instance, Visual Studio used to be an extremely expensive product. Well, now it's a free product if you want to use like the community version of it, which says, hi, I'm a single developer working on this project, and or it's me and like two buddies, and we're using our own collaboration tools external to this, so we don't get all of these things for a big team of people working together. That's what they're charging you for now. So same thing's true here, where if you want to use Unity's built-in collaboration tools, which I have never used, so I don't know how good or bad or whatever they are, but I'm extrapolating based on the way this would work with like Visual Studio. These are going to be things built into this that allow us to manage as you're making a change. I would see that change live and things like that. And also a way for us to communicate. Again, mobile app stuff, in-app purchasing things you can add in, multiplayer stuff. This is something we actually might mess with right at the end. I mentioned if we get to the first-person shooter stuff, but we'll definitely be working with this next semester. We might use Unity's built-in, or we might use an external product called Photon, which I've used quite a bit. We'll probably explore both. Typically, if I'm just using that as a starting point, Unity has a lot of the stuff. In fact, it's probably mostly fair to say Unity has all the things embedded within it that you would need to write a game. 98% of them. You know, every now and then you get some newfangled thing they haven't built into the thing. But just because it hasn't built in doesn't mean that their implementation is the one you want. right? So Unity's built-in multiplayer thing is generally, well, historically thought as not being as good as some of the other ones. It didn't scale to lots and lots and lots of players. It was kind of built initially to work for like 5v5 type first-person shooter type games, as opposed to like if you're building a massively multiplayer game where you might have 1,000 people online at once. It wasn't really good at scaling for that. So then some third-party products came out that allowed you to more easily or from a higher performance perspective, run a world with lots and lots of simultaneous people. Well, now the rumor is that Unity is actually the best in that game, but it's still a little weird because one of your game clients ends up becoming the server. So these are things to look at, but sometimes just because something's built in doesn't mean that you will actually use that particular feature, because an external feature might actually be better performance or do what you need it to do, things like that. And I've never used a performance reporting, but it says discover app errors. So it's going to be some sort of way. I'm thinking about it in terms of Xcode's tools called instruments, which allows you to kind of during runtime see memory usage and memory leaks and things like that. So in any case, this little tab for services is something we very likely will not look at very, 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 very often. But we will look at this thing called inspector often. And notice that it's currently blank because we don't have anything selected. Okay, but this is going to be a tab we're going to use often. All right, so leave it at that. Now, I'm going to move this stuff a little bit. So down here, we kind of have our file explorer dealy thing, and you can change the view of this a little bit. So 1-column layout versus 2-column layout. I like the 2-column layout better because you get them boxes of things. But down here, you automatically get a folder called assets. So your game lives inside of this folder called assets. All right. Now inside of here, notice they've already created a folder called scenes. So this might be where you keep all your scenes. So if I double click on the sample scene, they probably already have some stuff in here, I'm guessing, or is the sample scene sample scene's the current one they gave us. So here's our starter scene. You can throw it away if you want to, but you don't have to put your scenes inside of a folder called scenes. You can just, if you wanted to be disorganized, you can just throw everything right there in the assets folder and Unity doesn't care. Okay, but the bigger your game, the more organized you probably want to be. At the very least, you probably want to have a scenes folder if you're going to have multiple scenes in your game. I think I mentioned last time or the time before that you almost the way Unity wants you to imagine game design is almost like a movie. Okay, so you have different scenes in a movie. So, you have a set for that scene. That's going to be our interface for that scene. You might be inside of a building or something like that. And you're kind of putting all the stuff and all the moving parts related to that scene specifically in that scene, right? So you have actors, you might have your main game player that's in that scene, but that game player might also exist in other scenes, right? You go and see the latest, greatest movie, and you have your main, the main actor or actress. Well, that person's likely in multiple scenes in the movie, right? Okay, but they're still the same person. Okay, they have the same movements and stuff like that. I'm trying to kind of connect the dots between game programming and real life. So if we have our main hero for our game that can jump and shoot stuff and whatever it is, we want those abilities to transcend scenes, right? So we might have a scene that has very unique stuff that's unique to just that scene, but then we want our character to maybe live in multiple scenes. Similarly, we might have enemies. And, when you think about like Mario Brothers or something like that, the later you get into the game, they start introducing new enemies, right? But you still do have some of your old enemies, or at least things that look a lot like your old enemies. But for the first several worlds, let's say, or first several levels in World 1 of Super Mario Brothers, you still got the little turtle dudes, the little mushroom dudes, right? So you want to kind of design your enemies and you want to have them be players in different scenes, okay? So let me stop there for a second. So when we talk about a scene, this guy is going to be a collection of what's called game objects that make up the visual and, I'm going to say mechanical, might not be the best word, components of, I'm going to say in quotes, a level in the game. You could potentially have levels that live across multiple scenes. So I use that word loosely. But generally speaking, if you're thinking about like a Super Mario Brothers game, even though that's the older ones were just 2D, you have this big, long, scene, right? And, the camera is only looking at this part of it. And as Mario's going, the camera's following along, right? He jumps, the camera jumps with him, that kind of stuff. Okay. So when you get to the end of it, you do the little jump thing onto the flagpole. I'm not sure why he's doing that, but whatever the reason he's doing that, that's the end of that scene. And then they show the next scene. There's usually a little launch screen, and then you're in the next screen or the next scene, and the Mario dude is now placed into that new scene, and now you have the same monsters and that kind of stuff. Okay, so you really want to think about scenes almost from a movie perspective, that whenever something changes in your game, whether it's gameplay or scenery or things like that, you're probably going to be starting a new scene. So we can think of that, this is probably being related to a level, but some games don't have the idea of a level. Okay, so if we kind of connect this to, like we were talking about Skyrim earlier, Skyrim is one of those kind of big open world type of games, right? So the world for Skyrim is big, right? So how do you think they implement that? Is that all in one giant scene? Well, maybe it depends. How many of you have ever played one of those games where you feel like you're in a big open world and you're running around, and all of a sudden there's kind of like a loading pause, or even you might even say, loading. Yeah, I kind of remember back. Any of you ever played? This might be before your time, but the game EverQuest. Okay, so EverQuest, kind of let's call it the original MMO. All right, so this was kind of like World of Warcraft-y type game, but way back before World of Warcraft. If you're a World of Warcraft player, similar to, how many of you in here have played World of Warcraft for any period of time? Okay, so if you're, but what I'm about to talk about is the same for any of these open world games. You can run forever and there never is a reload, right? You just keep going. And the thing that I remember from EverQuest that was kind of funny is you would be running ahead. So let's say that, this is the world we're in and there's this door here. So I'm running towards the door, and from my perspective, I'm just going to run right through the opening in the door and I'm in the hall. But that's not how EverQuest worked. You'd be running to that door, and all of a sudden, it was completely invisible to you, but that was the zone line. That was the end of that scene. And then it loaded the next scene. So there was this pause, more than a pause. It might have been a 20-second load time for you to get into this next scene. But it used to be in that particular game, one of the things you had to work with was this idea of, you have people screaming, such and such monster to zone. Because in that game, monsters didn't run back to their start point when they were done chasing the thing it was mad at. When you disappeared on them, they just turned on whatever the nearest. Yeah, so you could really screw with people in that game. It was kind of funny, but it changed the dynamic of how the game worked. So as people were running, they would yell over general chat for the zone or zone chat and say, such and such monster to zone. And that told people to get out of the path where the zone exit is, because some bad things are coming there. Okay, but that was an example, kind of an older way of doing this that had to take into some considerations the constraints of either the hardware or the game engines of the time, things like that, where only so much stuff can be loaded into memory at once. Well, now if you're playing Skyrim or you're playing World of Warcraft, you can just run around forever and there's never a load time. Now, behind the scenes, there actually there are some things. If you've noticed in, so I'm just going to keep using World of Warcraft as an example because I have a lot of experience playing that game. Even though if I'm running from here to here, I still might move into a different zone. So World of Warcraft calls them zones. And even though there was no load time for me, when I entered a zone, I left one zone. This is more from the networking side of things. You leave one zone and you enter another zone. And at that point in time, it's probably picking up all the network connections for the other people that are in that zone, keeping track of the monsters that are in that zone. So even though from the user's perspective, it's a giant open world, the game at any point in time only is keeping track of things that are kind of relative to what your experience would be. Make sense? Now, World of Warcraft isn't completely open world. They do draw it at continents. So they have an entire continent that you could run from one end to the other on and never have a reload. But then you have to take like a boat or an airship thing from one continent to another, and that's a reload. Okay, so they do have some sort of limit, but you kind of see the advances in technology where what we would consider to be today a modern open world game exists today where that would not have existed a while ago because of multiple things, amount of memory and stuff like that. One thing you probably also see today is, and this is what kind of makes games like, Skyrim is actually probably a good example. You know, we've seen, well, first of all, Skyrim has all those mods and stuff, but in terms of the official releases of Skyrim, the original one came out, and for its time, it was considered to be pretty good graphics, right? Certainly pretty good graphics relative to the size of the world. Typically, the smaller the world you have, or if a game is level-based or something like that, the much more intricate the graphics can be. Because if you're in a big open world, you could almost think of it from the perspective of a particular scene can only have so many polygons in it or something like that. It's an oversimplification, but it can only have so many graphical units in it. So the bigger the world, the less graphically intense you likely can have the components in that world and still keep up. For, let's call it the average machine. If you have the latest, greatest, turn on ultra graphics and stuff like that, maybe you could keep up with something better. But in general, when a game like Skyrim came out originally, they were, kind of ahead of their time for how big that world was and how good the graphics were for that. And when you really think about it, how long do you think a game like Skyrim probably took them to make? Is that something that took a month or two, or is that something that took a couple of years? Yeah, I mean, this is a giant project, right? So how good are the graphics going to be in 2 years from now? What's the computer hardware going to be in 2 years from now? Could we take a stab at it? But we don't know, right? We're trying to look at past trends for where it might be. But at some point, there's going to be a giant leap, right? We've had leaps in the past, and presumably we'll have a leap in the future. I don't know whether it's going to be the quantum computer stuff or just more cores, or we're finally going to get past the heat wall and have same number of cores, but now we're back to faster cores. Who knows? Who knows where we'll end up being? But in any case, if we're making a game today, and it's a big game, we're going to be making little stupid tiny things that last a week or two, right? A little bit different. We're pretty sure we know what the computing power for us is going to be in 2 weeks. It's going to be the same machine that's sitting in front of you right now. But if you're writing a big game, you have to think ahead. What is stuff going to look like in 2 years? Because you don't want your game to look great on today's stuff and look mediocre in 2 years' stuff. So you have to design for the future. So when Skyrim first came out, it was thought to be, a pretty impressive looking game and a pretty impressive size and detail of the world for its time period. Well, and it was a really popular game, blah, blah, blah. Well, after a while, the game itself was still popular. It was it's one of these famous games that people always point back to as being this really, good accomplishment. Yet the graphics no longer were as impressive. So what did they do? They did a facelift of the game and then re-released it and collected your money again. It's a great business model. And it worked. They've done it. What have they done? At least 3 times. They did the original, then they did the graphics update, then they did the VR. Was there another one in there? There might have been another one in there. I kind of recall like some anniversary-ish version. You kind of know what I mean? Yeah. There was some other... They probably gave you a figurine or something with the box. I don't know, but it was something. Oh, they might have had. What are you talking about? Different games? Or are you talking about?
I'm pretty sure it's one that published with them.
Oh, yeah. I think you're right. Where you could also get Skyrim.
Yeah.
Yeah.
I mean, how many times have they re-released it on a new console?
Oh, you're absolutely right. Yeah. I think this is the really sad thing. I think I've bought Skyrim 3 times, and I've never actually gone farther than killing the first dragon.
Yeah, seriously. It's like, I mean,
And it's not that I don't didn't enjoy it. It's that I think as you get older, and most of you who are gamers sitting out there now, you maybe won't conceive of this. When I was your age, I was big into games, sit there playing for hours and stuff like that. And I thought, oh, that's just my thing. I'll always do that, right? I mean, there's different kinds of games because I'm a little bit older than you guys. But the point is that I don't do that anymore. It's like it doesn't hold my interest like it used to. VR has rebooted that a little bit, but you can still only play for so long. But I find it interesting. I've never, and the only time I even got to the dragon, I was on. If you remember Nick Schumacher, he's like a YouTube and Twitch streamer guy. Like, I don't know, he's like kind of a big deal in that world. I don't know, but I was on his show, and he streamed his professor playing through the first dragon of Skyrim. It was funny. But in any case, they've re-released this game a bunch of times for money grabs, and that's always going to be the business side of things. We don't care about that in here. But the point is that each time they've added something that's related to the current world of games, either better graphics. Now they've done the VR thing. They attach it to another product, as he pointed out. Yeah. In any case, we see that fairly often. And the bigger the game, the bigger the world, and the more number of players, chances are the trade-offs you'll have to make. So, for instance, there's a game currently in for VR. It's for Vive and Rift called Orbis VR, and it's effectively a game that's it's an MMO, so it's along the lines of like a World of Warcraft or something like that. Big open world. There's a little loading time between scenes, but not very much. Like it's like a little pause. But it's a big open world, much, much, much smaller than like a World of Warcraft in terms of the open world from a necessity perspective. And there's live players playing all the time. You can just go right up to somebody and just start talking to them using your voice. I mean, it's a really cool experience. But if you're comparing like the graphics of a modern day MMO to that, far cry. Let me actually probably show you. Yeah, this is like gameplay of it. But these are all like real characters, real people. It's actually better than this. This must be from a beta. People have faces and stuff now. It's the Oculus and the Vive. And it's really good. Yeah. So, the idea here is this looks a little bit more like what they were. This guy has like a face and stuff. But what you've seen here is you have, first of all, the people who are playing the game, a large percentage of their computation power is being used to drive that VR headset. VR needs a good computer, so even though the Oculus Rift has come down to $399 and the Vive is $499 or whatever now, that's just the beginning of it. You need to have a machine that can drive it. And really your starting point for playing VR today, let's call it at a reasonable level, is probably a GTX 1070 from NVIDIA. They say they support the 1060. They also say they support the 1050 Ti. You're going to have to turn some stuff down. You're going to notice frame rate issues and stuff like that. 1070, you're good for VR today. 1080, you're great. 1080 Ti, you're, as far as what you can buy today, that's going to be your best experience.
180.
Huh? Well, you can't buy it yet. And we'll see. The speculation is that, well, and if you're in the computer architecture class, we've been talking about this recently. What you're probably going to see is you're going to see drastic performance increases in very, very, very specific things. So what you use your graphics card for, you'll have to decide, does that benefit me? That kind of stuff. So, in any case, the trade-off here is the game has to look substantially simpler in order for them to accomplish all the things that you can do in the game. And it's really fascinating. I mean, you can just stroll right up to somebody and just start talking to them just like you're in real life. You don't have to press enter on the keyboard or something. You just talk. And it's all proximity-based talking. And so there's so many things that a game like this does right. It's currently still in beta, but it's like, they have regular releases. It comes out every week or two. There's a pretty big update. They have big raids, they have dungeons, and I mean, it's just a very interesting take on things. If you're looking at a feature set for it and you're trying to compare it to, a modern day MMO on PC or something like that, it's not going to hold up from a feature perspective. But when you consider you're completely immersed in it, you go in there, you're in a whole different world, and you're traveling around, and it's fascinating. And we do have it on the machines in here. If sometime you want to come and check it out, I have it on my account, and you can just create a new character. But in any case, we have trade-offs when we talk about games, when we're targeting, a certain audience. If you're going to have your world be bigger, you probably then have to have your graphics be worse. If you're going to have multiplayer in a world, you're probably going to then also have to have your graphics be worse. So one thing you might see, some of the best looking games today are the games like Witcher and stuff like that are single player games. Even though it is a relatively big world, it's not completely open world. But point is, they're only having to make the end user experience good for one person. And they're not having to deal with all this extra networking overhead and other things that are going on. So they can dedicate all your computation power into making that game look good. So those are the games that are likely going to look the best today. You start getting into more multiplayer stuff, they don't look as good, or they don't perform as well. That kind of stuff. All right. But punchline for us here is we have this thing called a game object. And that's going to be a pretty important thing for us. So we're going to say anything in Unity comes from the base game object. So for those of you who had object-oriented programming before, whether it's Python or Java, something like this, when you do object stuff, in that hierarchy, at the very, 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 very top, you have a class called object. So if you create a dice object, or you create a cat object or a person object, even though you didn't inherit from anything, it still was a generic object. Same thing's true here in Unity. Every single thing that exists in Unity comes from, has a great ancestor that is game object. Okay, so it's going to be very common for us to have things that pass around game objects, and then we have to turn that game object back into what it actually is. All right, so because we're going to be carrying something that might be having something in our game that might be very, very, very specific. Maybe it's an animator. Well, an animator does all sorts of stuff that a game object doesn't do. But if I have a container built for holding a game object, I can put an animator in there, because an animator is at its core a game object. But if I want to start using it as an animator, I need to turn it back into an animator. But game objects are kind of our primitive type, our main primitive type in Unity. So everything ends up becoming a game object. So let me flip back to Unity here. All right, so we have our scene here. We're currently operating in this sample scene. You notice up here in the hierarchy, it says sample scene. They've already given us two things. We've given us a main camera, and they've given us this directional light. So think of the directional light kind of like the sun. Okay, so they've lit our scene for us, whatever. We're not going to worry too much about lighting most of the time in here. And our main camera, if you click on that, you see your camera preview is down here. If I hit play, we'll see the same thing that we just saw from that camera preview. Beautiful, just a beautiful game, okay? So, and this camera is something we can move around if you want to see. It's a little camera thing, but notice it has 3 little arrows coming for this is the X, Y, and Z axis, all right, for this. So when if I double click on the camera, it'll center it on the screen, so I can work with that. If I double click on the directional light, it centers that. Camera centers that. Okay. If I want to then zoom in, this is the scroll wheel equivalent. I need to get my mouse before we go too much farther into Unity. Next class, probably. So it's easier than using a trackpad. But in any case, you can zoom in, you can zoom out, all this stuff. Now, up here, you can choose which axis you're looking down. So for instance, right now, we're looking at it from a center view. That's this thing if you click this reset thing in the center. But let's say I want to look straight down on the scene, because when you're working with a 3D scene, sometimes it's hard to tell if you're looking at it like this, maybe you think, oh, yeah, my dude is in the middle of the village. Maybe you have this village or something that you're building. But if you look straight down on it, you realize he's actually out there in the middle of nowhere, because the village is way over here. And when you looked at it from the X or the Z axis, he looked like he was in there, but he's actually, depth-wise in a different place. So sometimes it's easier for you if you click on the Y here, you can look straight down on your scene. Let me show you a different example of this. So over here on the right, on the left, on the hierarchy thing, I'm going to right-click, and I'm going to create a 3D object, and I'm going to go ahead and create a plane. So these are all game objects, but these are kind of our primitive shapes, okay? So I'm going to create a plane. For us, we can think of planes as maybe being kind of floors. It's technically a 3D object, but it's a sheet, okay? So it's flat, and it's rectangular. We can change its shape, but that'll put it on the scene. Now notice, so right now I'm looking at this plane, and you can't even see it, because I'm looking at it straight on the x-axis. And what if something has a width of nothing? I'm seeing a line or something like that. But if I go from above, where's my mouse here? Now I see the plane. Make sense? Now there's my main camera, so I can kind of see it under the plane there. But there's a situation where I can, let's say, slide the plane over here like this. Now I switch to the main camera. Notice that the main camera, if I look at the camera preview here, it's showing the camera's pointing out this way. So my plane is nowhere near where that camera is. If I want to move this guy, take him this way. Then I'll take them this way. I go back to my main camera. Now, I would have expected to see it there, but I don't, because I'm probably at the wrong level. So now if I go this way, notice that my camera is looking right at that thing dead on. So I can elevate my camera like this. Notice now in the camera preview, you see the thing show up? Because when I was right on it, it disappeared into the horizon because it was a flat edge I was looking at. So one of the things it'll take some time to get used to with Unity is how do you lay stuff out in the scene so that you can see it? Because initially when you're working in this 3D space, things aren't as obvious. So now if I go ahead and hit play on this, now I will see I have this amazing game ready to release. We just have a floor. Okay, so this is one of our primitive types called a plane. And this guy is a game object. He's just a game object. So now if we look at what a game object has by default. So here's my game object. We have this thing called a transform. Let's go back in here. So all game objects have something called a transform. Okay, now a transform says two things. We might call this guy we have a position and we have a scale and we have a rotation. So it's 3 things actually. So a transform is position X, Y, Z, scale X, Y, Z. So that's a scale on the X and the Y and the Z axis. And then a rotation on X, Y, Z. Okay, so a transform is a object that contains 3 other objects that keep track of information about a particular game object. So if I go back in here, notice our transform here has a position. So the position on this guy is X is -28, Y is 1, Z is 85. If you hover over the X or the Y or the Z, you get these little arrow things. You can actually drag it and move it around on there. So you'll find little tricks, better ways of kind of moving things around, doing things. You could also just hard code the thing. If I want this to be a 0, just put 0 in there. If I want this to be on Z, -85, but I want it to be a 0, now it's there. So what have I done? I've made the Y 1, that's pulled it away from where the camera is, because if I go to where the camera is, notice the camera is at position 0, -10 on Z, but we've actually put it up in the air a little bit. So it's up in the air. If I move this, so it's 2.84. If I just move it to a 3, now it's kind of up there, pointing at it a little bit more. Before, instead of being at the exact same level, if I put it at the exact same level on Y, now it's gone. But actually, is it gone or is it below it? Because wasn't this guy at 1? That guy was at 1, so it's actually below it. But if I throw it up to 3, now it's in the sight of my camera. Okay. So similarly, so my camera has a position. Now it has a scale. I'm not going to do it with the camera. I'm going to do it with the plane. So scale for the plane, I'm going to make it bigger on the X. So I can make it bigger, smaller, whatever on the X. And I can make it bigger on the Z. Now it's kind of a big playing field now. Now, if I make it bigger on the Y, I don't think a plane gets any thicker. The nature of a plane is that it's always effectively paper thin. So if you need a floor, for instance, that is, I want to actually back up here. I want to make sure what I'm telling you there is an accurate statement. Oh, another thing to keep in mind there. So I was in play mode there the whole time. Now, if I go back to my plane, know that none of those changes I did stuck. So if you're in play mode, this is something that that'll commonly happen to you. So if you're playing the game and you're making some changes to see something in the actual scene, those changes will be gone as soon as the other thing's gone. But one thing you can do, so I'm just going to go ahead and stretch it out, scale again. Okay, so I have it at an X of 5.4. If I decide, oh, that looks good, before I stop playing the game, I can come up here to the little gear, and I can say copy component. And what that's going to do is it's going to copy all this transform information. So now I can come down here, unhit play. Plane is now back to where it was, but I can go to the little gear here, and I can say paste component values, and now it took it to the 5.4. So if you get it set just the way you want it to when you're doing testing during runtime, you can get those values and copy them over. But do remember that if you're doing all this tweaking, one thing I've seen people do, they might spend 10 minutes tweaking it perfectly in runtime. Forget that they're in runtime. Start clicking on stuff like, oh my gosh, why isn't anything clicking? Then you realize, oh, I'm actually running it right now. You stop it, and all those changes you spent 10 minutes doing are now gone. Go ahead.
Is it like I know how in Blender, once you make your object and edit it later on, you know what I mean? Can't resize it. Is it the same thing? Or can you do it?
Oh, you can resize it forever.
Okay.
Yeah, always make changes. All right, so I'll go back to my plane here. I can't currently see the plane. Now, one thing you can do is you can right click, and that turns into this little eye looking thing, and then you can move around. There's another guy here. This is where the mouse, a real mouse, comes in handy, because you can kind of move yourself in a different position. So I'm just going to click on Y to put me up above it so I can see it. But in any case, that is, now we have a camera that's looking out over that plane. If I want to move this guy around or something like that, if I want to go and look at this on the Z axis, do I want Z or do I want X? Yeah, there's the X axis, so I can see. I'll zoom in a little bit. So I can see now that that camera is out to the side of that plane. Now, if I want this camera to angle down onto the plane, I can mess with its rotation. Now, you can click on the camera itself, and then, so you can mess with this rotation in terms of numbers over here, or you can click on these various buttons over here. So here's the rotate tool. So right now I am on the move tool. So the move tool gives me the little arrow guys here. I see 2 of them right now, but if I go above, I'll see the other 2. Well, I'll see the third one. I want to be on X, there we go. But if I change it to the rotate tool, notice now I have these little circle things. So I'm going to go ahead and I'm going to try to grab something here. So now I'm rotating it on a different, so I'm kind of pointing it down. And then I'll move it back to the move tool. And I'm going to move it up. And then I'll move it back. Something like that. Okay, so I can mess with the camera, rotate it, all sorts of stuff like that. Doesn't matter that we're doing this to the camera, we're doing this to a cube. Just so happens the camera is a little bit more than a generic game object. It also looks at the scene. Okay, so if you look over here at the inspector, I currently have the camera selected. It has a transform, just like every game object has. That's a location, rotation, and scale in the scene. But it also has this component associated with it called the camera component. All right, I can make any game object a camera component if I want to. It might not make a ton of sense, but you can. All right, so I can make this guy, he has this camera component. So a game object not only has a transform by default, it can also be a collection of other components. So a collection of other components, okay, where a component can be a whole bunch of different things. Too many to list right now. Okay, all sorts of different stuff, rigid bodies and colliders and mesh renderers, and there's a gigantic list of things they can do. And these are the things that differentiate one game object from another game object. Okay? Okay, so even though we have a camera here and we have a plane here, notice that the camera has a transform, the plane has a transform, so both of those are game objects because we see a transform there. Okay, but notice that the camera has 2 components. It has a camera component that has all sorts of subcomponents in it for, what the field of view looks like, all sorts of other stuff. Then it also has this audio listener thing that's associated with it, which we'll play with as well. If I go click on the plane, I didn't add anything to this plane, right? This is what a generic plane came with. Transform, because it's a game object. It also came with a mesh filter for the plane that allows us to see the plane. Well, actually, the renderer allows us to see the plane. The mesh filter allows us to see the plane as an opaque object. Then we have this thing called the mesh collider that allows things to bump into our plane if we so choose. And then we have this default material. So when we think about color in our games, so let's go back here. So one of the components that we might be interested in is the material component. Okay, this is a component of a game object that gives, among other things, the color of the game object. I'll say, when I say among other things, I'll show you in a minute. Okay, so maybe we don't want our floor to be the generic white floor. Maybe we want a different material. Now notice the default material is this white material. If I hit this drop down on it, here's the among other things, notice that none of this is changeable. Okay, so because I'm working with just the core default, this comes with every single thing. It's just meant to be a placeholder. If you want a different material on there, you better make a different material. So I'm going to go into my assets folder. Now I can just create a material out here in the middle of nowhere if I want to. So I'll go ahead and do that. I'm going to right click down here inside my assets folder. I can do it over here. I can do it over here on the left. Doesn't matter. Okay, and I'm going to say create. And here's all sorts of stuff I can create. I can create folders. I can create a C# script. We're going to spend quite a bit of time doing that, making new scripts. I can create shaders, blah, blah, blah. I'm going to go down and find plain old material. So I'm going to create a material. And what color do we want to make our floor? Green. So just in case we want to reuse this guy, we'll call this our green material. It's also going to give us a, it'll show up as green in a few minutes. I wonder, can I zoom on this a little bit? Doesn't seem like it. Whatever. All right, but right now you see it's still like the generic material, right? Okay, so what I'm going to do is I just clicked on this material here. I haven't attached it to anything. And in the inspector, notice that this guy has information associated with it. Now, is this a game object? What's it missing? What do all game objects have? Transforms. This guy does not have a transform. So this guy is a component. This is the material component. All right, so components, as we say on this the previous slide, is a part of a game object. So game objects have a transform. We can say a transform is a component of the game object, and then it has a collection of 0 or more other components. Make sense? Okay. So we'll go back into our material component here, and I'm going to just click on this albedo thing. There's a little thing where you can go and find a color too, but I'm going to just click on this dude, and we're going to choose green. Yeah, perfect. It's the perfect shade of green right there. Oh, I didn't select it. Give me a moment.
Use the square.
Oh, I got to select it on here. Good call. I was testing you. There we go. So now I have this green, whatever, green thing. And you can mess with omissions and tiling if you want this thing to be, to have a floor that looks like it has almost a texture to it or has like squaring and stuff like that. We're not going to spend very much time in here trying to make things look good. Couple reasons. First of all, it's not what the programming side of things is about, and also it's not necessarily a skill set I have. So that would be more of, you mentioned like a Blender skill set. So that's going to be that 3D designer type skill set. Those folks are going to spend probably more time on design than the programmer, obviously, but still might not be the core designer person. That might go on to more of the art multimedia designer who's going to be thinking about lighting and this stuff like metallic reflection stuff, emissions, things like that are going to be off the programmer's radar. Not that we couldn't learn about those things, but if you're really focused on making a game look good, I guarantee if you look at a game like Skyrim or Witcher or whatever, it's not the programmers that made it look that way. The programmers made it work that way. Okay, you hit A button, dude swings giant sword. What the giant sword looks like doesn't matter. It was a weapon that was in the guy's hand. Programmer said, play this swing sword animation. Make sense? All right. So now I have this material that I've called my green material. And it's interesting. It hasn't really changed its view down here. You can see it's green up here, but I'm going to go to my plane. Now, a couple different ways you can do this. I can drag the green material over here directly and make my plane green. So now you see it's kind of green. I'll go look straight down on it. Now we have a green plane. Alternatively, I'm going to go ahead and I'm going to reset that, turn back to white. Okay, so, I'm actually going to, it's funny, it won't let me remove there we go. I just undid. So it wouldn't let me remove a default material from that because it needs a material for it to show up. But one thing we could do, we could either drag something from here directly over to the inspector, or we can drag it onto the scene, onto our object, and let go, and then that adds it. Typically, I have found that I drag more things over to the inspector, because sometimes, especially as your scene starts getting more and more complex, you find it more difficult to hit certain areas on the you might, instead of hitting the floor, you might hit the building next to it or something like that. Okay, so I usually try to work with stuff directly in the inspector. Go back to the camera now. You see we have a green floor. If I hit play, you see now I have, obviously this is the beginning of a forest. Well, you got grass in the forest. Well, not all forest. This is a grassy forest. Yeah, go ahead. Oh, I thought you had your hand up. Everybody during class, hands at the side, always touching your hips. Just all right, so that's one component we can add. If I go back to plane just in our last minute here, if I click add component, notice we have, here's the big list. There's a lot of stuff. These are all folders that have things inside of them. All right, one of the things that we will commonly put in here, and I'll just do it real quick. I'm going to go ahead, I'm going to make this guy a rigid body. All right, now a rigid body says this guy now has mass. All right, I'm going to go ahead and hit play on this. Physics, okay? My floor just got fat, okay? And now had a mass of 1, so I mean, it didn't fall real fast. But there was a gravitational pull on this thing, or push, pull, whatever. Gravitational push, let's say, on the plane at all times, but not until we added a rigid body to it did it feel that impact of the physics. Okay, so those are some things you can do. Now I can say I want to turn off gravity. Hit the little checkbox there. No longer use gravity. Hit play. Now it's not going to go anywhere. But being a rigid body might still be important because we might want other things to interact with it from a physics perspective. So I might want to put something else above it. Let me just do this real quick. Actually, we'll do it at the beginning of class next time because I want to mess with collisions a little bit. All right, so I'll put your new Bible homework up. We're going to be starting to do our first little thing for us. So if you haven't already done so, make sure you get Unity installed. I would go ahead and get in there and start getting familiar with the interface a little bit. I will start moving around my interface a little bit next class, so you'll kind of see, and you'll see why I do it, but I'm just showing you the default initially. I'm going to move this guy over here to the right. Just there's a reasonable reason for that. But in any case, go ahead and open up Unity, create a project, create a plane, mess with the camera a little bit, maybe throw a material in there. Just start getting used to using some of the stuff. Go ahead.
Will it save automatically, or do
you have to save? If you try to exit it, it'll say, you're going to lose your changes. So just hit Control S rather, or go up to File and Save, and it'll save that scene. But it'll scream at you if you try to close it without saving. Cool. All right. I will see everybody on Thursday. Remember that we have chapel right now. I'm going to go sit in the front row. You're invited to sit in the front row with me. God sweeps through the chapel and it hits the front row just a microsecond first. Okay, at least that's what Pastor Smith, well, I said that to him and he didn't disagree with me. So it must be true. All right, I will see you on Thursday. Make sure you look for the new Bible homework. I'll put it up today.